Now in this lecture we are going to create deletion method in double linked list. Now as you remember, in our previous lectures we have created double linked list class like this. So here we have implemented various methods. Now here we are going to implement deletion of a node from double linked list. Now here I'm going to declare our method like this. So the method name will be public void delete node double linked list. Now as a parameter, as we mentioned before, it's going to take one parameter, which will be the location. So based on this location parameter, we are going to identify that if we want to delete a node from beginning of double linked list, or from any given location, or the last node from double linked list. Now, according to our algorithm that we discussed in our previous lecture, the first step is we have to check that if our double linked list exists or not. So how can we check it? So if we check the head reference, so if head reference equals to null, then in this case it means that the double linked list does not exist. So here, if head equals to null, I'm going to print out to the console saying that the double linked list does not exist. So system out print the double linked list does not exist. Now then we are going to return, because we don't need to continue, because our double linked list does not exist, so it doesn't make sense to continue to delete a node because there is not any node in our double linked list. In the else condition, we are going to check that if location is equal to 0, it means that we want to delete a node from the beginning of double linked list. So which means that we want to delete first element from the double linked list. Now we know that when we want to delete first node from double linked list, we have two cases over here. Now the first case is if we have only one node in our double linked list, and the second case is we have more than one node in our double linked list. So I'm going to implement them separately. So here, if size equals 1, in this case it means that we have only one element in our double linked list. So this means that here all we have to do, we have to break head and tail links between this node and head and tail. So first I'm going to set head to null, and I'm going to set tail to null, and with this we have successfully deleted the link between head and this node, and the link between tail and the first node over here. Then we are going to decrease size by 1, because here we are deleting one element from the double linked list, so size has to decrease by 1. Now then in the else condition, we are going to implement the case in which we have more than one element in our double linked list. So this means that if we want to delete first element in our double linked list, so the conditions will go here. So in this case, all we have to do, we have to change head reference to point to the next node, and a previous reference of second node has to point to null. Because in case of double linked list, the first node's previous reference is null, and head always points to first node. So if you are deleting first node, so in this case, head has to point to the second node, and second node's previous reference has to be null. So in this case, I'm going to change head to set head next. So in head now we have first node's physical location. So if we access head.next, we are accessing the second node. So in this case, we are creating a link between head and second node. Then we are going to set the second node's previous reference to null, because in this case, if we set the head to head.next, in head now we have second node's reference. So this means that if I put head.previous, it is accessing the second node's previous reference, and we are setting it to null over here. Then I'm going to one more time decrease the size over here, because here also we are deleting an element from the double linked list. Now then we are going to continue to the next condition over here, in which we want to delete an element from the end of double linked list. So this means that we want to delete last node from double linked list. Now in this case, I'm going to put else if condition like this. If location is greater or equal to size, this means that we want to delete an element from the end of double linked list. So we want to delete last element. Now when we are deleting an element from the end of double linked list, here also we have two cases. So this means that we might have only one element in our double linked list, or we might have more than one element in our double linked list. So I'm going to implement the logic over here. But before doing so, we need to create a temporary node which points to the second last node. So in this case, I'm going to create temporary node with the type of W node. Then temporary node will be set to tail.previous. So with this, we are setting this temporary node second last node in the linked list. Then we are going to implement our conditions over here. Now here again, we are going to implement the same condition that we implemented when we are deleting a node from the beginning of double linked list. So this means that if we have one element in our double linked list, the conditions are same because this node will be the first node and this node will be the last node. So this means that I'm going to just copy this code from here and put it over here as our if condition over here. So if the size of double linked list is 1, so in this case it means that we have only one element in our double linked list. So when we have one element in our double linked list, all we have to do, we have to set head and tail references to null to delete an element from the double linked list. Now in the else condition, we are going to implement a logic in which we want to delete a node from the end of double linked list, but we have more than one node. Now in this case, I'm going to write the logic like this. So if the temp node is going to be the last node in our double linked list, so the first thing that we should do, we need to set temp node's next reference to null, because in case of double linked list, the last node always points to null. So that's why I'm going to set temp node's next reference to null. Then we need to create a link between tail and this temp node over here. So all I have to do, I have to set tail to temp node, and then one more time we have to decrease the size by 1, because here also we are deleting an element from the double linked list. Now in the else condition over here, which belongs to this if condition, we are going to implement the logic in which we want to delete an element at any given location in double linked list. So here the first step that we are going to do, we need to create a temporary node in which we have head value, because we are going to loop through the head until we find the location that we want to delete a node. So here I'm going to create Doubly node as temp node. So now in this case it's going to take head reference. Now then we are going to loop through the double linked list for I int starts from 0 until we reach the location -1. So location -1, and in each time it's going to increase by 1. Then each time we traverse to the next node, so that's why I'm going to put temp node equals to temp node.next. And then when we reach the node that is located before the node that we want to delete, here all we have to do, we have to create a link between current node and the node after the next node, and we have to create reverse link between them. So here I'm going to set temp node's next reference to temp node's next.next. So with this we are creating a link between current node and a link between the node that is located after the next node. Then we have to create a reverse link. So I'm going to set temp node.next, in which we will have now the node that's located after the next node, and .previous. If we put previous over here, we are accessing the previous reference of that node, and we are going to set it to temp node. So with this we are creating backward link between these nodes over here. Then at the end we are going to decrease the size by 1. Now with this we have completed our method. So in this method we have combined all 3 cases of deletion in double linked list. So here we have implemented the logic of deleting a node from the beginning of double linked list, then the logic of deleting a node from the end of double linked list, then the logic of deleting a node at any given location in double linked list. Now let's see how this is working in practice. Now here inside main class we have created a double linked list like this, in which we have 4 elements. So then we are traversing this double linked list. So after traversal, I'm going to call delete method, and I will check various locations. So for first example, let's check the deletion of location of the first element in our double linked list. So after deletion, I'm going to traverse one more time through the double linked list to show the difference before deletion and after deletion. Now if I run our code, now you see that initially our linked list was like this. So then after deletion it becomes like this. So this means that if you put 0 parameter over here, we are deleting first element. So initially first element was 2, but here now first element is 3. Now if I try for example something 9, which is greater than the size of double linked list, in this case if I run our code, you will see that it's going to delete the last element from double linked list. Now in this case last element was 4, but now it has been deleted, so the 1 becomes last element in our case. Now if I put for example index of 1 over here, which will delete the second element from the double linked list, in this case our double linked list will be like this. So as you see, the second element was 3, but in this case second element becomes 1. So 3 has been successfully deleted from the double linked list. Now let's see what is the time and space complexity for this method over here. Now here, as always, we are going to start first line of this method. Now in the first line we are checking head reference and printing out to the console the message saying that the double linked list does not exist. So we know that this if condition takes O1 time complexity because here it's just a simple if condition and we are printing out message to the console. Now then we are continuing to the next if condition. So in the next if condition we are checking just location parameter, if it is equal to 0 or not. So this part of code will take O1 time complexity. Then inside this if condition we have another if condition in which we are checking size parameter and we are setting head and tail references to null, and then we are decreasing size. So this part of code also will take O1 time complexity because these are simple assignment statements. Now if we continue to the else condition of this if condition, we see that here also we are updating the references of head and previous reference of head, and we are decreasing size by 1. So this 3 line of code also will take O1 time complexity. Now if we continue to the next part of code, in the next part of code, we are checking that if location is greater than 0, then we are creating temporary node in which we will have second last node's reference. So this part of code also will take O1 time complexity because here also, as we said, we are just creating temporary node and this is a simple if condition over here. Now if you go to the inside of this if condition, we see that we have another if condition over here in which we have already said that this part of code takes O1 time complexity. So this means that this part of code also will take O1 time complexity. Now in the else condition, we are setting temporary node's next reference to null and tail to this temporary node, and one more time size decreased by 1. So this part of code also will take O1 time complexity. Now when we come to the last else condition in which we are creating temporary node and setting head value to it, so this part of code will take O1 time complexity. Then when it comes to the loop over here, we see that we are looping through the double linked list until we find the location. So if you put for location n over here, and it's going to loop until we reach n-1. So this means that the time complexity will be O(n-1). So if we eliminate the constants from the time complexity for this loop over here will be O(n). So this whole loop over here will take O(n) time complexity because here inside we are just setting temp node to temp node's next reference. This means that this will be O1, so the O1 will be eliminated from here. The whole loop condition will take O(n) time complexity. Now if we continue to the last part of code, here we are updating the current node's next reference and then we are updating the next node's previous reference. So then at the end we are decreasing the size, so this 3 line of code will take separately O1 time complexity. So if we combine them, the time complexity for this 3 line of code will take O1 time complexity. Now if we combine all these complexities over here, we get O(n) time complexity because as I mentioned before, O(n) is dominant term over here, so O1 time complexities over here will be eliminated. Now the space complexity is O1 because in this case, each time whenever we are calling this method, we are just deleting a node from double linked list, so this means that this is not a time consuming operation. Now with this, we have come to the end of this lecture. So in this lecture, we have combined all 3 cases of deletion in double linked list in one method and we have implemented them in practice. Then we have checked that if it is working correct or not. So we have seen that everything works the way that we want. And at the end, we have learned what is the time and space complexity for this method over here. So hopefully everything is clear about this method. Now, see you in the next lecture.